Water Resources Engineering 2, Unit 1, Gravity Dam. So, a dam is a structure constructed across a river to store water on its upstream side. So, the stored water may then utilized for water supply, irrigation, hydropower generation, navigation, etc. So, the main purpose of dam is to make provision for the safe retention and storage of water on its upstream side. After knowing the basic idea of gravity dam, arch dam and buttress dam, now then comes to the earth and rock fill dam. So, now in earth dam that is made of the soil which is locally available, and they are built in areas where the foundation is not strong enough to bear the weight of concrete dam, and where earth is more easily available as a building material compared to concrete or stone or the rock. But in case of the rock fill dam, the rock fill are formed of loose rocks and boulders piled in the river bed. So, a slab of reinforced concrete is often laid across the upstream face of a rock fill dam to make it watertight. Now, the Tehri dam, that is the earth and rock fill dam, that is the combination of both. The advantage of this earth and rock fill dams, the earth dams can be constructed almost on any type of available foundation, and they can be constructed rapidly with relatively unskilled labor and with material available on the spot, and they are generally cheaper than other types, and they can be subsequently raised in height without much difficulty if such a needed arise in future. But the some disadvantage of these dams, the fail suddenly without sufficient warning, and they can be used as overflow, they cannot be used, okay, they cannot be used as overflow dams, and they require heavy maintenance cost and constant supervision. And now here is shows in last figure, that is the Tehri Dam, and that is the earth and rock fill dam. The first is gravity dam. So, a gravity dam is a permanent hydraulic structure which resists all external forces acting upon it by virtue of its own weight. It is theoretically triangular in shape and is to be constructed on solid sound rock foundation. Even though its initial cost of construction is high, but it requires very little maintenance after its construction. The most ancient type of gravity dam constructed in Egypt of uncemented masonry dates back to 4000 years BC. The archaeological experts are of the view that this dam was maintained in perfect good condition for more than 45 centuries. The gravity dams are suitable for U-shaped valley or gorge having steep side slope where solid rock foundation are encountered at reasonable depth of about 10 meter. So, the highest concrete gravity dam in the world is 285 meter high, that is the Grand Dixens Dam in 1962 in the Switzerland, and in our country the height of Bhakra Dam, that is the 226 meter. So, a gravity dam is the one in which the external forces are resisted by the weight of the dam itself. Thus, the forces disturbing the stability of the dam are resisted by the gravity force of the mass of the dam. So, a gravity dam may be constructed either of masonry or concrete. So, masonry gravity dams are nowadays constructed of only small heights, and all major and important gravity dams are now constructed of concrete only. So, a gravity dams may be either straight or curved in plan. The site selection for the gravity dam, the sites for the gravity dams should satisfy the following requirements: the availability of good construction material in sufficient quantity near the construction site, and the foundation rocks should be sound and strong, capable to resist the static and dynamic force includes earthquake force. The abutment slope and valley slope should be stable, and the suitable location for the spillway and powerhouse should be available, and the facilities like electric and water supply line, road and rail communication should be available near the construction site. This is the section of gravity dam. Here the water is stored. So, this portion means where the water is stored, that is known as the upstream side, and the other side that is known as the downstream side. And here means this point on the upstream side, that is known as the heel, and the other side that shows the toe. Okay. And this is the body of the dam, and now here is providing the some drainage gallery. So, then reducing the some uplift pressure, and here shows the maximum water level, and the some portions of this gravity dam that will be the vertical on upstream side, and this some part that will be inclined. Okay. Axis of dam, this is the very important during the construction of this the dam, and also that is important for the designing of this gravity dam. So, the upstream vertical face, or the line of the crown, so means at the top of the dam, here the vertical line from the crown, that will known as the axis of dam. But in case if suppose this is the means upstream face, that is the vertical, So then this is the axis of the dam, but in case of the dam are the sloping from the means up to the crown or from the crown. So then the line is vertical line is drawn at upstream side of the crown. This vertical line that will known as the axis of dam, or this is the baseline of the dam. So, with the help of this line, now then the construction as well as the design is considered with respect to this line. So, this is the very important while in designing as well as in construction. Forces acting on Gravity Dam. So, now the following or the various forces are acting on the Gravity Dam, that is water pressure, weight of dam, uplift pressure, pressure due to the earthquake force, wave pressure, silt pressure, ice pressure and wind pressure. Now, these 8 forces that is the very important while designing or the stability criteria for the Gravity Dam. So, now in figure that will shows the some idea about this one, the different forces. So, now the water pressure is acting on upstream side as well as on downstream side, and now this water pressure, that is the major disturbing forces, and the weight of dam means due to this weight. Now, here this weight means self weight of the dam that will resist the all the disturbing forces, because due to the gravity. Uplift pressure that will be acting just below the dam, because this water will be the seeping and now it will exert some upward thrust, that is so due to this upward thrust, that is known as the uplift pressure, and this uplift pressure is reducing the weight of the dam. And the pressure due to the earthquake forces when the dam is located in earthquake zone. So, now these dams are the subjected by the some earthquake stresses. Wave pressure is acting at the maximum water level, and now it will some also the exert the some forces at this level. Silt pressure. Now, the silt that will be deposit at the bottom of this the river or just behind the dam. So, it will also give the some silt load, additional load of the silt. Ice pressure, when the dam is located in the cold countries. So, now the some ice that will be means formed at the water level. So, then it will also the exert some forces due to the variation of the temperature at this level, and also the wind blowing on upstream and downstream side. So, due to this wind, now it also gives the some forces. So, means all the forces are acting and also take the moment about the toe. This is the very important moment about the toe. So, means the anti-clockwise movement that will gives the resisting forces and clockwise movement gives the disturbing forces. So, means when the reservoir in full condition, the movement is taken about the toe, but in case of the reservoir empty condition, all the moments are taken about the heel. Okay. So, now that we will discuss in later. Okay. So, now this is the general idea about the forces which will acting on the gravity dam. Now, here is also the showing the different forces with this diagram. Here the first is the water pressure. So, this is the water pressure, that will be the hydrostatic water pressure on upstream side as well as on the downstream side, and weight, that is the self weight of the dam, that will acting here, and uplift pressure just below the structure of this dam, and the pressure due to the earthquake force. So, this is the hydrodynamic pressure, and this variation is not hydrostatic, and also the wave pressure. So, wave pressure are acting at the water surface, and the silt pressure. So, silt pressure, that will be the bottom of this means up to the certain height of that will acting the silt pressure, and ice pressure, that will be acting at the water surface as well as in wind pressure. So, now these are the different forces also are acting on this diagram. Now, so again here it also this shows with the help of this diagram, the different forces are acting on the gravity dam. Here this shows the number 1, this is the water pressure. So, now this water pressure that will shows on upstream side vertical, horizontal as well as vertical. So, horizontal, that will acting, that is the hydrostatic, but in the vertical forces, that will be acting when the upstream face, that is the inclined. So, some the weight of water are rest on this inclined face. So, similarly, now on the downstream side, this is the hydrostatic pressure horizontal, and vertical, that will shows on inclined face, and all the forces or taking the moment about the toe. So, then the some forces, that is the resisting forces, and the some forces, that is the disturbing forces. And the next number 2, this is the weight of the dam. Weight of the dam is acting downward and taking the moment about the toe. So, that is the anti-clockwise. So, this is the resisting forces. And uplift pressure, here that will be shows just below of this dam. So, then the water is the seep through this one. So, then it will exert some upward thrust, that will give the some uplift pressure. So, this is the uplift pressure diagram, and taking the moment about the toe. So, this is again it will comes out the clockwise. So, this is the disturbing force, and the pressure due to the earthquake forces. So, this is the earthquake force, this is the hydrodynamic force, and this is the variation of this hydrodynamic force, means this is the 4th number, and it will also give the some disturbing forces, because the moment about the toe, it will be the like this is the clockwise. Ice pressure and wave pressure, that will be acting at the water surface, and the silt pressure that will acting, means this is the 7th one, that will shows here up to the certain height, and also the wind pressure. So, now these pressures, these forces are discussed one by one in the next presentation. So, just here in this presentation only knowing the different forces are acting on the gravity dam. So, in this presentation now discuss about the Gravity Dam and the different forces are acting on the Gravity Dam, and now these different forces, that is the water pressure, weight of dam, uplift pressure, forces due to the earthquake, wave pressure, silt pressure, ice pressure and wind pressure, and now these 8 forces are very important. And now in the next presentation, now we will discuss one by one, because this is the because these forces are disturbing the stability of the Gravity Dam. Now these forces now to understand very careful. Okay. So, now in next presentation we discuss the different types of the forces which is acting on the Gravity Dam. So, thank you very much. You have any problems, you can contact me at any time.